Hello, this is Mr. Kessler, and welcome to the video Quadratic Equations Graphing Edition. Today our objectives in this video are to graph quadratic functions of the form y equals ax squared plus bx plus c. What makes it quadratic is the highest degree monomial is to the second power, so therefore this is a quadratic equation. And our other objective to graph quadratic functions by identifying the axis of symmetry and the vertex. So one way to graph a quadratic equation is to create a table of values. So why don't you create a table of values for this function, y equals negative 2x squared plus 2. Pause the video, create a table of values. Excellent. I've created a table of values. I use negative 2, negative 1, 0, 1, and 2. I know it's a quadratic equation, so I know my graph is going to be a parabola. So after I plot those points, I can then connect the dots. And the reason why we like to graph quadratic equations is it's an easy way to identify the roots of the function, especially when you can't factor the function easily. So in this case, the roots are where we're crossing the x-axis, and they are estimated somewhere around, well, right exactly on 1 and negative 1. It can be very time-consuming, though, to create a table of values. So here's another way to estimate the graph of a quadratic equation. So first clue, you're going to look at the a term. Second clue, find the y-intercept. Third, identify axis of symmetry. And fourth, then find the vertex. So looking at your first clue, the a term. If the a term of your quadratic equation is positive, then your parabola is going to open upward and the vertex is a minimum. If the a term is negative, then your parabola is going to open down and the vertex is a maximum. So you do it. Identify the vertex of the graph, and is it a minimum or a maximum? Pause the video and write down your answers. So the vertex in the graph was negative 3, 2, and it is a maximum because it's the highest point on your graph. My grandmother's name was Verna. Axis of symmetry. So here's another clue that can help you to estimate a graph of a quadratic equation. You can use this formula, x equals the opposite of b over 2a, to determine the line of symmetry. Like if you were to cut the parabola in half and fold the graph, it would be symmetrical all around that line of symmetry. So in this first case, the line of symmetry is right here, and there's an equation for the line of symmetry. It's x equals 0. The equation on the other side, negative 2x squared plus 4x. We can use the line of symmetry formula. It's x equals the opposite of b over 2a to determine what that line would be. I know you can look at it and estimate that it's going to be x equals 1. Let's make sure that this formula works. So the opposite of b, in this case, the b term is positive 4, so the opposite of that is negative 4 over 2 times the a term, which is negative 2. So negative 4 over negative 4. X equals 1. So the line of symmetry in this case is x equals 1. Now let's talk about a couple more clues. So in this, if we were to estimate the graph of this equation, let's find the a term. It's positive 1. In fact, what I like to do is I write out what all of the a, b, and c terms are. I write them right underneath the quadratic equation. Now I can use that. So the a term is positive, it's 1, so therefore my parabola is going to open up. What else do we know? The y-intercept. We can identify the y-intercept is positive 4. So let's go ahead and graph that, put a dot at positive 4. Now our axis of symmetry, the line that's going to cut the parabola in half, our parabola that's going to be opening up somehow. So let's check this out. X equals the opposite of b over 2a. So the opposite of b. B is negative 6, so the opposite of negative 6 over 2 times the a term, and the a term in this case is 1. So the opposite of negative 6 is 6 over 2, so the axis of symmetry is at x equals 3. So we can go ahead and draw our dotted line on x equals 3, meaning our parabola is going to cut that in half. Now, one thing we also know for sure is that our vertex is going to be on that axis of symmetry. Right? So our vertex is going to be on that. It's going to be lower than our y-intercept because our parabola needs to open up, right? So our vertex could be here, here, here. Who knows? That's the thing we have to determine. And the way to determine the vertex is to take the x value and substitute it into the equation. Y equals 3 squared minus 6 times 3 plus 4. So y equals 9 minus 18 plus 4. 9 minus 18 is equal to negative 5 plus negative 9 plus 4 is negative 5. So our vertex is at 3, negative 5. As confirmed, our graph is going to open up. Now, the other thing that we can also identify is that if our y-intercept is going to be equidistant from the line of symmetry on the other side. So that means we're 1, 2, 3 away from our line of symmetry, so we're 3 the other way. So another solution in our quadratic equation is going to be here. And now we can estimate our roots. They're going to be somewhere around 1 and somewhere around 5. But we know for sure it's not 1 and 5 exactly because this quadratic equation can't be factored easily. So it's going to be an estimate around 1 and 5. Now it's your turn. You estimate the graph of the quadratic equation below. Pause the video and use the 4 clues to estimate what the graph looks like. Great. Hopefully you did this successfully. The A term is negative, so the graph is opening down. The y-intercept I identified as negative 2. The axis of symmetry, the opposite of the B term is 4, so the opposite of that is negative 4 over 2 times A. So x equals 2 is my line of symmetry. My y-intercept is going to be equidistant on the other side of the line of symmetry. I could put another point at 4, negative 2. And the last thing to figure out is the vertex. So if x equals 2 on my vertex, then I plug in 2 for x and find out that y also equals 2. So the vertex is at 2, 2. Hopefully you did that well. Now complete the 9.1 quick check on Google Classroom. Remember, you got to get a perfect score before you are complete. You can take the quick check excuse me, as many times as necessary. Any questions, just send me an email.